Guys, I will continue tutorial from using this diagram. Okay, so another one important thing you need to know in vector is usually the question will come out is something like this. They'll say this is the question A B, and then I'll draw an arrow up there. So I'm going to tell you what is actually this arrow indicate in this. So this arrow will tell you I'm traveling from A to B. Okay, I repeat again, this arrow is actually showing I'm traveling from A to B. So a little uh, understanding about this kind of diagram, usually if we move towards our right, we denote as positive, and normally if we go to our left, it denote as a negative. Vice versa, if we go up is positive, we go down is a negative. So now the question says I want to go from A to B. Please write in a vector form. So I can either write in this matrix like I taught you earlier, or I can write the ij, up to me, but I'm going to show you both lah for understanding of. So now the question say A to B. So from A, I want to go to B. So from A go to B, I have to go through 1, 2. That means on my x, I need to travel 2 steps. I repeat again, 1, 2 on my x. So I'm going on towards positive side. So I'm right here, 2x. And then from this point to go B, I need to go up. I repeating, go up. Go up means positive. So I'll move 1, 2, 3. So it become 3 here. Or I can write in the vector, the ij form also. Both of these is the same answer. Okay, it's acceptable. Let's say we do a bit more. Instead of A to B, I want to go from B to C now. For example, I repeat again, from B to C. How I know I go from B to C but not C to B? Because the arrow is pointing, the arrow is teaching you, hey, I'm going from B to C. So from B to C, this is a bit tricky. So from B to C, I have to go 1, 2. That means I go towards my right by 2. So I will write here by 2. Then from here, I want to go down. See, you are learning something. I'm going down. So going down means I need to add negative. By how many I go down? 1, 2 lah. So I go down by 2. You can either write in a matrix form, or you can write in the ij form. It's the same thing here. So moving forward, let's say I go another one example. Sorry, I don't have enough space. Let's say I want to find from D to A, guys. Okay, so for D to A, same thing, I can write like this or ij form, doesn't matter. So let's see. I want to go from D to A. So you see, from D to A, I'm going towards my left. So I'm going to a left means first thing I need to do is I need to add a negative here. Okay, so how many I travel? 1, 2, 3, 4. So I move by 4. Okay, sorry, my writing. And then from here I move up by 1. Up means positive, so I just write positive. Or you can write negative 4i plus j. It's the same thing. Last one for this tutorial will be from D to C. D to C is interesting. Okay, reason why, refer to the diagram. So from D to C, do I need to move left and right or not? No need, right? I just have to go up. So there's no movement left and right. No movement is 0. So I also can write a 0 I here. And then I just have to go up by 2. So here will be 2. Or in a ij form will be 2j. Of course, you don't have to write that I, also can just write 2j here. Okay, so I have illustrated to you the working based on this diagram. Okay, I'm actually utilizing your textbook. If you have your textbook, you can go to this chapter 29.1 on this page 532, and you can see all the examples there. Okay, so now that we have learned how to extract information from the graph, we'll just do very quick few exercise here, then I will go to the PowerPoint there. So let's say I want to do AB. Okay, so for example, I want to do AB. So how do I do AB? Actually, I want to go from A to B. Okay, so you can write any form, and yeah, this is one good keyword. They say column vector. Column vector means is matrix form. This is what we call as column vectors. Okay, your ij I'll find, usually there's another keyword for ij, but remember, if they mention column, then you must express in this matrix form. If they didn't mention column, then you can just express in ij form, no problem. Okay, remember, column means matrix. So A to B, A to B, I'm moving left or right? I'm moving right, so that means positive. So let's count how many. 1, 2, 3, 4. So I move by 4. And then from A to B, at this point, I'm going to go down. So go down means I must add a mandatory negative with 1 because I moved down by 1 step. So done. Now let's look at DB. Okay. So for DB, so how I know DB? Because the arrow already showed D to B. So we refer to diagram. D, I'm going to B. So I need to go to my right. 1, 2, 3. Right means positive. So 3 here. Okay. And then from this point here, I need to go up. I go up means positive. So just write 1. Okay. And then let's say we do a little bit hard one. Let's see, we have C to A. C to A seems interesting. Okay, we do this lah. So now we have CA here. Okay. So for C to A, what we can do is we need to move left by 2 steps. If you notice, 1, 2. Okay, I repeat, 1, 2. So if move left means what? I'm moving this side. That means I need to add a mandatory negative 2 here. Then I'm going up. Up means positive. So 1, 2, 3, 4. So it's 4. Okay. So this is actually how we express vectors from diagram directly convert to column vector. Okay. I repeat again. Matrix form is known as column vector. Okay. So that's pretty much about a vector. And then since we're in this page, I want to take this opportunity to explain to you how do we actually do addition and subtraction of a vector. I mean, I would actually want to tell you why we have to learn the addition and subtraction of vector, because it's quite important. Just let me just clear this space off for you. Okay, so yeah, just give me a second, guys. Please, I'm so sorry if I didn't edit this video out of this part, or because the truth is I'm not good in editing video. I'm just good at delivering content. Okay, so yeah, so we are here. Okay, very quick, I'll get the tape out so the paper don't move around. Okay, and then yeah. Okay, so now if we look here, another one important thing I just want to explain to you. So in vector, usually we will learn this thing called resultant vector. And those advanced students will know. Those who are not advanced students, you can learn now. Like so, vector usually will illustrate in a triangle form. Okay, so in vector, it's very important for us to identify what is resultant. Okay, so resultant actually in physics you learn, so doesn't matter, we just focus on the basics of maths. Okay, so resultant vector means what, okay, so now let's say I have a vector going in this direction, this resultant must be opposed the flow. What I mean opposed the flow, you see the same triangle we can draw in another way. Instead of like this, I can draw like this. Notice not. So it's a complete circle. We don't want this complete circle. We want to have two vector and one opposed to 4. Usually the opposed is what we call resultant. Okay, so why is this thing so important for us? Okay, so referring to just now the textbook example. Okay, let's say I have a vector from here going to here. Okay, so I want to know what is this vector. So let's say this point is 1, here is 2, and then here is 5, here is 6, for example. Okay, so I want to express this vector in this form. Okay, so if you notice, what are we doing actually? You see properly. I want to know, let's say this point A, point B. I want to know what's my vector AB. So what I'm doing here actually, I'm finding from here I go to here is how much. Okay, so if you notice, from here to here I move 1, 2, 3, 4. Okay, so this will be 4, and then from here I move to up 1, 2, 3, 4. So 4. Okay, so some of you will be wondering what is going on here. Actually, as you don't know, I'll crop this part out.